Hey y'all, in this lesson, you're going to get introduction to the basic trigonometric functions. We have a scenario here that I'm going to use to introduce this topic, just to kind of show you the need for these trig functions that we're going to be using throughout the course. So you're going to be seeing these functions over and over and over again. We're going to learn everything there is to know about these functions. We have a situation where we're building a ramp for skateboarding. The ramp must have a height of 3 feet. It's always good to draw pictures in trig or geometry. And the angle of the ramp from the ground, see if I can get this drawn. I should have done just one triangle. I'm going to fix that. Sorry, guys. See if that works. Yeah, that's better. Is 11 degrees. How long will the ramp be? So we know it's a right triangle, and we know one of the sides, but it's not a special right triangle because of the 11 degrees. So we're kind of like, kind of stuck, right? We have too many unknowns. This brings us into our trig functions. Our trig functions are going to help us solve this problem. So I'm just going to kind of introduce you to them. And first, we're going to talk about some terminology before we get into that. I have a triangle here. It is a right triangle. And I have an angle labeled here. We'll call this theta. So that's the Greek symbol for theta. And we're going to use theta a lot. So you're going to get used to that Greek symbol. And we've learned in previous lessons that the two shorter sides are called legs, and then the longer side is called a hypotenuse. And that's still true, but we're going to expand our vocabulary a little bit and use the words adjacent and opposite. So when we are talking about a specific angle, so in this case, we're talking about this angle right here, the side directly next to it is called adjacent. And if you look up the word adjacent, that's what that means. It means right next to. And then the side across the way is called the opposite side. And we have some definitions of trig functions over here. There's a lot of background into why they're defined this way, but we're not going to get into that for this lesson. We just want to have the definitions handy. These are things that you're going to need to know and use over and over and over again. So if you have a running piece of paper with formulas and stuff on it, then definitely put these on there. And you're going to be using them a lot. So much so that you probably won't have to memorize them. You'll just know them because you use them so much. Okay, so by definition, the sine of this angle, I'm on this one right here. The sine of this angle is the opposite side divided by the hypotenuse. The cosine of this angle is the adjacent side divided by the hypotenuse. And the tangent of this angle is opposite divided by adjacent. So this is probably like a lot of information right now. And some of the things that I want to go over before we move on is the pronunciation of these words. So this word is pronounced sine, like a stop sign. And the abbreviation for it is S-I-N. We don't say sin. It does look like sin, but that is pronounced sine. So when you see this abbreviation, you say sine theta. And then cosine, pronounced cosine, is abbreviated C-O-S. When you see this word, you don't say cos, you say cosine, okay? It's just an abbreviation. And then tangent is tangent, T-A-N. And then we have some reciprocal functions. And these reciprocal functions, if you know what a reciprocal is, it means basically you just flip the fraction. So cosecant is the reciprocal of sine. So I put them side by side here, 1 over sine. So if we flip the fraction, that becomes hypotenuse over opposite. And then secant is the reciprocal of cosine. So flip that fraction. And cotangent is the reciprocal of tangent. So flip that fraction. So for me, sometimes I get a little confused because this starts with COS and this starts with COS. So sometimes I'm like, oh, those are reciprocals, but they're not. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. And again, we're going to be using these like so much over and over and over again. So you will become accustomed to all of this. But something that you can use to help you is a very popular memory device. It's called SOHCAHTOA. And if you've ever taken geometry and got to this point, then you've probably heard of this. It's very popular, but it can really help you narrow down what these identities, these functions are. So stands for sine theta equals opposite over hypotenuse, OH. Ca is cosine theta equals adjacent, over hypotenuse. And TOA is tangent theta equals opposite over adjacent. And so if you can just remember the memory device, then that's a little less room in your mind that you have to reserve for that. And then now all you have to know is which reciprocal functions go to what. So sine is associated with cosecant, and then you flip that fraction. Cosine is associated with secant, flip that fraction. And then tangent is associated with cotangent, flip that fraction. Okay, a couple things I want to point out here that might help you. When you're writing the word tangent, a lot of times if you use a little curly T, that's going to help because a regular T is going to look like a plus sign, so be careful there. And then another thing I want to point out for me that was helpful when I was learning this, when trying to decide is cosecant with sine or is it with cosine, which one is it with? A little memory device that I did for myself was COS is opposite of, they kind of look like the same when you flip them, like mirror image. I don't know. If that doesn't help you, don't use it. If you don't see it, don't use it. But it did help me because this word kind of looks like this word backwards. Kind of weird, but hey, what works for you, do it. All right, moving on. We're familiar with our functions now, and we can use them to solve problems where they are not special right triangles. So we're finding the values of the 6 trig functions using this triangle and angle A as the angle that we're focusing on for setting up our functions. So this angle, we would consider it theta, but it actually has a name. It's A. Theta is kind of like X. It's just kind of a general variable that we use. But in this case, we have the angle A. All right. So before you get started setting up your trig functions, it can be very helpful to go ahead and just label your sides. And then that way you don't have to think about it every time. So the easiest side to label is the hypotenuse. It's right across from the right angle. And then opposite of angle A is over here, which leaves adjacent to angle, oh my goodness, I joined 2 letters into one. Adjacent to angle A is the one that it's right next to. It's very, very close. So I've labeled my sides, which means now I can set up my trig functions. I've got sine A, cosine A, and tangent A. And then I've also got cosecant A, secant A, cotangent A. So that's all 6 trig functions. Sine A, remember SOHCAHTOA, so is opposite over hypotenuse. And then if you reduce by 3, we get 3/5. Cosine A, ca, is adjacent over hypotenuse. Reduced by 3, we get 4/5. Tangent is TOA, so opposite over adjacent. Reduced by 3, we get 3/4. So these are our first 3 trig functions, and then we're going to use those to find the remaining 3. Remember that the remaining 3 are reciprocal functions, so we just have to flip the fractions. We've got 5/3, 5/4, and 4/3, and that's it. That's all it's asking for. In the next example, it is a right triangle, and we need to find the 6 trig functions. Now, if I go, what are we talking about? Angle X. That's kind of my reference point. I am given the opposite, the adjacent, and there's no hypotenuse. Well, there is a hypotenuse, but I'm not given the hypotenuse measure. So that means that before I can even set up my trig functions, I have to find the hypotenuse. And that's going to be very simple. We're just going to use the Pythagorean theorem. Goodness, got away from me. 5 squared plus 12 squared equals c squared. That's going to be 25 plus 144. That's 169. And then you take the square root and we get 13. So our missing side is 13. Now I can set up my 6 trig functions. So I want you to go ahead and pause this one, try to do all your trig functions, and then come back and check your work. Okay, you should get sine of x is 12 over 13. That's opposite over hypotenuse. Cosine of x is 5 over 13. That's adjacent over hypotenuse. Tangent x is 12 over 5, opposite over adjacent. And then for the reciprocal functions, you're just going to flip all those fractions. Now for the last example, we have an isosceles right triangle. These are important words. That means 2 of the sides are the same, which means 2 of the angles are the same, which means it's a 45, 45, 90 triangle. The legs are length 2. Find sine, cosine, and tangent of both acute angles. Now, I did say, it does say both acute angles, but the angles are the same. So we're really only just doing like one problem. You don't have to do sine A, sine B, cosine A, cosine, all those because they're the same. So if you just find one angle, you found the other one. But before we get started, we only have the legs, which means that we have to find the hypotenuse first. So go ahead and try to find the hypotenuse, pause it, try it, come back. Since this is a 45, 45, 90 triangle, I used the ratio associated with that. If you did the Pythagorean theorem, that's fine too, but we were given the legs, so x and x are 2, and then the hypotenuse is 2 root 2. It helps me, especially in trigonometry, to go ahead and draw a picture. My picture is not to scale, but you get the idea. My hypotenuse is across from angle C, which is 90 degrees. Which means that angles A and B over here are 45-degree angles. And our goal is to find sine, cosine, and tangent of the acute angles, or one of the angles, since they're the same. So I'm just going to use angle A. So sine A, cosine A, tangent A. And then remember, it's helpful to set up your sides. This is opposite, this is adjacent, this is hypotenuse. And then now do the problem. We've got so ka toa. So I've done just the preliminary work. Now I need to simplify a little bit, because you can see in sine and cosine that we've got square roots in the bottom. So we need to do what's called rationalizing the denominator. And to do that, it's a fairly simple task. We multiply by the square root in the denominator on the top and the bottom. These are going to be the same, so we're just doing the same problem twice, basically. So on the top, we have 2 square root 2, and on the bottom, we have 2 times square root 4. I'm going to go over here. Sorry about that. 2 square root 2 over square root 4 is 2. So 2 times 2 is 4. And then if we simplify the coefficients, or the coefficient with the denominator, we end up with divide by 2, divide by 2. I'm going to leave the 1 out of this because I don't need it. And that is what we're looking for. I do realize I go a little bit fast on rationalizing the denominator and multiplying and simplifying and stuff like that. Basically, since this is trigonometry, you've had algebra before this, so I do kind of skip over that a little bit. But if you feel like you're struggling in that area, please reach out to me and let me know, and I can give you some helpful hints and stuff like that to walk you through it. And then this one is the exact same, so we don't have to do it twice. And this one is simple. 2/2 is 1. So, and then if you did angle B, it would be the exact same because those sides are the same. So we could go ahead and say sine B is also √2/2. Cosine B is √2/2. And tangent B is 1. Same. All right, that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.